Hello, hello? Hello, hello? Hello! That just sounds better. Hello and welcome, everyone. There is some chairs still up front here, so in case you please don't stand the whole thing. There's some people coming in back there, so I just want to let you know there's some chairs up front. So welcome everybody to DuckCon number 6. It's hard to believe it's already number 6. And people always ask us what was DuckCon 1 because we can't see it on the website. It was actually on Zoom because there was a plague. So the DuckCon number 6, it's number 6 here in our hometown, and I would like to welcome each and every one of you who came out. I've heard some stories of people traveling from very far, and I have to say we are quite flattered. I also want to sort of maybe not warn you, but inform you that this is the first time that we are live streaming DuckCon to everybody, hello world, to anybody out there. And that is also the reason why we are in this particular time slot, because it sort of works for everyone. So people in China, for example, can watch, and people in the US can watch, although it's quite early. So I apologize to everybody in the US for that. And we are doing this because we noticed that we are getting a lot of for example, visitors to our website that were from places that we haven't never done a DuckCon in and might never do a DuckCon in, and by live streaming, we can integrate everyone. Speaking of integrating, here's the QR code. It's also the same QR code as you have on the side there, and there's also an easy-to-remember domain name, qa.duckcon.org. So we're going to use Slido, which is this website for asking questions. So for the Q&A after the talk, I will read questions from the iPad here, and you can also upvote other people's questions. That will help me to prioritize the questions to ask. So again, the QR code is going to stay on the side here, so you don't have to immediately write it down. Just wanted to let you know. This event would not be possible without the wonderful sponsors. So obviously it's not free to run an event for free. So we're very thankful to Monday.com to being a gold sponsor for this event. And we're also very thankful to Real and Crunchy Data for being silver sponsors for this event. Again, a big thanks. Give them a round of applause for sponsoring. Yeah, and there should be some merch in your bags. Some people are also around. Go talk to them. But now back to the main event. We're talking here today. We're assembled here today to talk about DuckDB. And obviously, for DuckCon, for us it's also super interesting because we do not, always hear all the stories from users because we're sort of, fixing bug number 487 or something like that. So DuckCon is really meant as an event where people that use DuckDB can sort of talk to each other about what you like, what you dislike, things like that. This is really truly inspiring to see where our sort of wild idea from 7 years ago, I think, has led to, and it's really it's a pleasure to see you all here, as I've said. It's always a good idea to repeat the mission statement, right? So this is something I learned in one of my presentation courses. And it took us actually some years to figure out what this was, even though we had an intuition. And the intuition is really to move from this world where people generally fear large data sets because they make everything more complicated, to a world where you're no longer scared of this big pile of CSV files because okay, DuckDB is most likely going to handle it, and that will be it, right? So this is really and this is also where the motivation for DuckDB came from, was we saw people struggling with anything that didn't fit in Excel, and then so the tools available at the time were just not nice or not instilling confidence. So that's really where we want to be. And we're also helped by industry trends. So here is a very scientific plot that I made. No units. Excellent. But what has happened is that also in the short time since we started work on DuckDB, is that the capabilities of a single node in terms of processing data have essentially risen quicker than the growth of useful data sets. And actually made this slide a couple of years ago and predicted a data singularity, where like 99.9% of data analysis queries could run on a single node without any problems. And we thought, yeah, this is future work. But then it actually happened that people confirmed this quite recently. Here's a post from Fivetran from George Fraser, who analyzed public disclosed data from Snowflake and Redshift and showed that the P99.9 of dataset sizes was under 300 gigabyte, which is really shocking if you think about it after a decade of talking about big data. And Gabor here has actually done experiments on this, which neatly connects to the 300 gigabytes. So he has shown that we can actually run the industry standard benchmark TPCH with a scale factor of 300, which is roughly equivalent to 300 gigabytes of input data on a Raspberry Pi. So not just we cannot just these datasets are just not as big as we thought they were. The hardware that we have is also, together with software like DuckDB, shockingly capable in the sense of processing it. And if you add zeros to the number of the size of data here, we just have to go to a bigger computer. And on the right here, we actually recently ran scale factor 30,000, or Gabor did, on a machine with 96 cores. And you can kind of see how this single node capability is really growing. This is a slide I have always had at DuckCon, and you can see I have this old version of the slide here in this endless sort of loop into history that are just previous versions of the slides. I want to highlight some numbers on the adoption of DuckDB, which, as always, is blowing our minds. I want to highlight 3 things here. We have, in case you don't know, we have extensions for DuckDB for features that we don't really want to put in the core itself. And last month alone, we saw 32 million extension installs, right? So this is totally wild, where somebody typed in, install Postgres or whatever, and that's been done 32 million times. We've also saw a crazy growth in the amount of unique visitors to our website. We now are around 1.8 million unique web visitors per month, and it's funny because we accidentally made one of the bigger websites of this country. Right? I think we have beaten the Lidl at this point, for the people who know. And also, because of recent developments in social media space, we have started posting more to Blue Sky. We're also really happy to see a growing community there. If you're not on Blue Sky yet, I encourage you to do so. I'm also on Blue Sky, and the hashtag for data-related topics is just the best because it's DataBS. And you can just type DataBS, and it's perfect. So that's kind of the sort of super high-level intro. And next, we will have Mark, who's going to tell you a bit about the technical aspects of DuckDB in the recent months.
Hello. Thank you all for coming. It's great to see such a turnout every year. DuckCon, it keeps on blowing our minds. It keeps growing, keeps getting bigger. It's fantastic. And it's great to have you all here and see all the cool things that you guys are doing. Very excited for all the next talks as well. Previous years, we had the tradition of doing a DuckDB sort of up-and-coming thing. We are not really doing a big talk about that today, but nevertheless, I do still want to talk a bit about the things we've been working on in the near future and what we're planning. One of the things that I think is kind of critical to, or like a very cool future development that we have been working on and has been going on is the extension ecosystem. So you may have used DuckDB extensions before, either knowingly or unknowingly. Many of the things we do ourselves that we make for our users are extensions, right? Like the HTTPFS, the web connectivity, those are extensions. The Parquet reader is an extension. You can do a lot of cool stuff with extensions. I think it's one of the cool future directions we want to take the project is to enable the community to do all of those same things. So that's why we made community extensions, and we keep on working on making it more easier to use and easier to make and build these extensions so that you guys can extend DuckDB and do all kinds of crazy stuff, and so we don't have to, you don't have to push it by us. You can do it all by yourself. There will be some talks as well today talking about some of the very cool extensions that have been developed, so it's very nice. I want to briefly talk about this duck. This is the Harlequin duck. This is a duck that is native to the northeastern hemisphere that lives close to the oceans. Very pretty duck. It's also the duck that we have chosen for the next DuckDB release, DuckDB v1.2, that will be released next week. So if you haven't picked up yet, all of our releases are named after various different duck species. And this one is the Harlequin duck, or the Latin name, which is Histrionicus, which is releasing next week. We predict it will. There will be a blog post detailing all of the features in there. I think it's a very exciting release. But just to have some bullet points, the CSV reader has received a lot of love. It's even better now. We have some nice improvements to the friendlier SQL. The CLI autocomplete has been reworked. It's much better now. We've done a ton of performance optimization work. Many queries are a lot faster. And we're introducing the C API for the extensions that should allow you to build community extensions much easier. And we're introducing a lot of logging features to make it easier to productionize, to put DuckDB into production and keep track of what is actually going on. As for what we're doing next, well, we have tons of different things we're working on, but I think this year is probably going to be the year of this. There's a house on a lake here. You guys probably kind of can figure out what that is. The lake house things is most likely going to be our main focus. So that's it. Happy to talk about any of these things after, during the breaks or in the drinks after. And then I will now hand it over to the next speaker. Thank you.
We can do questions.
Oh, questions.
We do have time for questions.
Oh.
And I get to pick which questions we're going to answer, which is just not a conflict of interest in any way, shape, or form. But you have upvoted them. This is great. I can see that already. So I'll start with the highest voted one. If you could double your team tomorrow and focus on one major architectural change in DuckDB, what would it be and why? I will have Mark answer this very easy question.
Of course, we're going to do scale out, right?
Scale out, yeah.
No.
GPUs.
GPUs. No.
Yeah, no.
It's an interesting question. I think if we were to double our team tomorrow, we wouldn't do a big architectural change. I think we like our current architecture. We think it's been going very well. We would have more people to put on different projects, clients, integrations, and things like that, of course.
Yeah, this is one of the things that we're seeing right now is that the amount of client integrations that we have, like the Java client and so on and so forth, that is something that could scale better with more people. The actual engine work, we don't think could scale better. So that's something that we could put more people on. This is actually very active. Yeah. Any near-term plans to add support for partitioning? Yes. This is also something we're planning to work on this year.
Yeah, it's part of the lakehouse formats. They all support partitioning.
Yeah. What are the future plans for DuckDB WASM? Well, I don't know, to process queries, I suppose. But the WASM ecosystem, like the in-browser DuckDB, that's of course an ecosystem that's changing. The environment is changing fairly quickly, and so I think there's going to be some exciting stuff just from the browsers making more things possible. WASM moving into other places, things like that. But you could talk to Carlo, where is Carlo? There, back there, he's waving. So you can talk to Carlo if you have WASM questions. What do you think about DuckDB replacing some SAS workflows in the financial and pharmaceutical industries? I suppose you mean SAS, the statistical software, I think. I remember I've used it at university way back when. Didn't like it a lot. So from that experience, I think DuckDB could replace a lot of these workflows. No, but I mean, obviously, a tool that charges you 1,000 euros per person per year is gonna have to be much, much better against one that doesn't cost anything, just saying. Can you say a bit more about the upcoming lakehouse worth in relation to MotherDuck? I think these are orthogonal things. I think this is not really related to MotherDuck.
I mean, they will probably support lakehouse as part of that as well, but it's separate.
Yeah. Any plans to make it more easy to contribute to extensions? C++ is not my jam.
Yeah, well,
How could you not like C++? We love... No, okay, we get it. Yes.
Yes, absolutely. So that's one of the reasons that we're excited about the C API extensions. It's not because you can write extensions in C. It's because the C API is kind of this universal language you can use to write extensions in other languages. So one of the things we're planning to have already worked on is extension support in Rust, and maybe also in Go in the future.
Yeah.
So you can already develop extensions in Rust. There are some already. So.
Yeah, I think that's I think good for now. We have we're good on time. So obviously, just wanted to mention this as well. People with the orange DuckDB logo work at DuckDB Labs, so you can ask them any questions you want. The only thing I want to mention is that pull requests are not for sale. No? Okay, but I think that's good for now. So we'll move on to our next speaker, who I'm happy to introduce. So next speaker, very excited to have you here after so many years on the internet. Thanks, Rusty. Yeah, he's going to talk about the airport, which I'm really curious to hear more about. So,
excellent.
All yours. There's a zipper.
Thank you, everyone, for coming. And again, thanks to DuckDB Labs for having this great event. I feel really great to be here. So my name is Rusty, and I'm going to talk about airport. But you may know I've kind of taken it to heart to create a bunch of extensions for DuckDB. So if you have extension questions or how to build them, I can answer those too. But all about this talk is really about a dream I had. It's really about putting DuckDB in a place where it makes access to data inside enterprises or around the world universal. I think it's a tool that can kind of replace everything else we have out there to provide an interface to data. But getting back to the airport extension, the best way to teach I've found is through analogy. And I travel in airports a lot. And hopefully some of you have used them, but here in the Netherlands, it might be maybe just trains. But they let you go to faraway places, and we all know these things because we've all kind of taken flights. So the airport extension extends that analogy to say, we can now have DuckDB go to remote servers. We can use Apache Aeroflight, which is a great open source format and protocol to talk to these other external sources. And we can both do select and insert, update, and delete. But you might say, well, where can I fly to? I mean, I want to know, how do I get to Florida? How do I get to California? I'm from America, so these are my geographical references. But airport can take you to all the places like this. And I know we just spoke about the lakehouse formats. So there's a lot of them. There's some hipster ones coming out. We can talk to those. And I'm going to show you an example of that as our first this morning. But the big question is, how does Aeroflight work? It works like this. DuckDB is on the left. We talk to a thing called an Aeroflight server that can either produce the data or return the data, or optionally can talk to the data source. Now, DuckDB currently doesn't really talk to RPC mechanisms. This is a change. Now we're going to start to reach beyond the single core machine where we're typically running to other resources and other things over the network using gRPC. Why did I create it? And this is kind of in alignment with what Hannes and Mark were just saying. After writing so many extensions, I kind of got tired of writing extensions. I want to kind of lower the burden to build things into the system. I want to go faster. I love to use Python. I love to use JavaScript. I love to use code that's already written. So if I can find a crate or a PyPy module already out there, that's what I want to use. The airport extension lets you do that. But the best way to illustrate it is going through some demos. And I have 3 today. We'll probably get through the first 2. The first one I'm going to show you is one of the most requested features that I think the DuckDB community has really expressed is, how can I do Delta Lake with write support? We have an attach call that basically says, hey, I want to talk to a flight server at this gRPC URL. We're attaching it as a database name called Delta Lake. Then you just go in here and you can do create schema and create table. And that's all the magic you need to know as a user of DuckDB, as an SQL user. There's other details that I could talk about, but we're going to keep it today really at the high-level SQL level. And I'm happy to speak after about the lower-level things. So after that, you just do a general insert. It just works like any other DuckDB table. There's some differences, just like as if you travel to foreign countries, sometimes the laws are different depending on where you go. Transactionality may not actually follow with you to these external services, but we can talk about that. So you can do inserts, you can do selects, updates, deletes, create table as, all your general fun stuff. And just to prove to you that this does work, Here is the actual Delta Lake table on my local machine from those same queries. So that just kind of gets us out of having to have the in-process Delta Lake implementation not have write support. You can build this in whatever type of scripting language you wish. Now, as for more details, this example used Python and Delta RS, which is the Rust implementation of Delta Lake, and it does predicate pushdown, it does integration with the DuckDB catalog, and I'm also skipping over everything here on the gray lines. So we can do time travel, we can do road trains tracking, all these fun kind of real business professional features we're going to skip over. We're not going to talk about how you can get rid of Databricks jobs and run it with DuckDB, but you can. So stay tuned. Now, looking back at this picture, we just spoke about extensions written in Go. Arrow is a really great package because it has implementations in all these other languages. So you can write flight servers today in these languages that I've listed. I left out the Go logo. I apologize to all the fans of Go here. And we're also kind of going to skip over the details here. But the best explanation I have about Arrow Flight is there's cookbooks on the internet that can teach you how to do it. For today, look forward to a future talk about it, but it's going to be kind of this meme here, where I'm going to say, draw some circles and then draw the owl. So that's kind of the explanation you'll get this morning. But stay tuned. The second demo we have here is actually one close to my heart. So I've done a lot of work in quantitative finance, and to say I'm a machine learning person is not really true, but I think we all are machine learning people, believe it or not. I really want to integrate a package called AutoGluon, and it's a really great AutoML package, meaning it does all the ML magic for you into DuckDB, because I think there's a big divide right now between people that use SQL and people that use Jupyter notebooks. And I think those really can be the same people. You don't always have to do all your ETL work in SQL and then hand it over to some developer and they're going to run it on a Jupyter setup to get your results. So the most useful example I could think of last night was, let's predict the number of votes a Hacker News subscription post is actually going to receive. So I have a new service called AutoGluon, which is a flight server that just integrates AutoGluon. And it stores its data in here. We're going to create a table called HN Stories, which is a history of Hacker News posts and the number of votes that they received. I just grabbed this off of a Kaggle website. It was a single Parquet file. You guys understand how this works. You know, create a schema, create a table. We're already going. Now we're going to create a model. And the fun thing here is, like, we have this new table returning function called predictor fit, and it exists under the AutoGluon database. We're going to give it the name of the model we're going to make, the training data, which is the table name of where we just loaded, and the target column we want to predict called score. We'll say it's a regression problem. Regression meaning I want to know the value that will be predicted for that column. We'll give it 200 seconds to train the model, and I want a high-quality model. Everybody hanging in there so far? All right. Here's where it gets fun. So let's put some examples in here. I want to kind of know what the predicted votes will be for these headlines of these posts. Like, Gabber's going to post the DuckDB 1.2 release pretty soon. He needs to know, should he put new keywords in there? So rather than having him do a whole Jupyter notebook and a whole bunch of feature engineering, just use this, my man. Here it is. Select a title, the prediction, which will be the predicted votes, from predictor predict rows using the model name, and then this is a table in-out function, so I can actually supply the data I want to send to the predictor. And that's really flexible. And the other thing I'm putting in here is we also have a factor here called the time of the post. So we can say, oh, is Wednesday better? Is Friday better? Is before lunch, after lunch? He can kind of find out what time that is. Here's the results. This is what you get. It's just like selecting from any other table. There's a title of the post and the predicted number of votes that it will have. And that's it. You don't have to worry about model deployment, Python environments. It's pretty amazing, in my opinion. Now, I have some bad news for myself, though, because I was like, well, what happens if I put the airport extension on Hacker News? And as you can see, the score is only 12 there. You know, Gabber's headline of DuckDB 1.2.0, that's 34. Clearly, Hacker News is going to care a lot about that more than this extension. So I hope you like that. That's just kind of where Airport can go. And all of that meant you're writing no C++ code. It's just Python code. And we're going to kind of give you good examples of that because it's already out there. I know there's a lot of people that do geospatial, and this is kind of our bonus demo, which I'm glad we're getting to. Geocoding is a big challenge. Geocoding is a process where you change an address into a latitude and longitude, or you go in the reverse of saying, I have a latitude and longitude, and give me where I am actually located. Now, I wanted to know where the White House is. That's where 1600 Pennsylvania Avenue is. Here's the latitude and longitude for that. Here is another example of here where we can have a geocoder service where we could take an address and then grab the current weather conditions. So I used to live in Miami Beach. This is the current weather as of last night down there. And this is a scalar function returned by Airport. And the interesting thing about scalar functions is we're not invoking the remote scalar function. We're actually going to get the vectorized batches and do those requests. So it's not a one-to-one call to the remote RPC endpoints. This leads to a lot of great efficiency gains. Now you might say, another term for this is called distributed scalar UDFs. And this is kind of a little bit more of a detail of the implementation. So I was at the office yesterday, and we wanted to just kind of give the simplest example. Here is just an example of a flight that uppercases the string. We define an input schema. This is in Python, so this is a definition of PA means pi arrow. The input is a string, the output is a string, and then process is just a reference to the next function I'm about to show you of how to actually perform that operation. If you know Python, it's going to say, all right, I got a pi arrow table as my input. I'm going to return a list of rows on the output, all of them with a dictionary called result that just uppercases the values. And that's all you have to write to implement a new scalar UDF in DuckDB. And here's the example of how it's actually called down below. So it's just geocoder is a database name that we were working in, USA is the schema, and uppercase is the actual function. So in review, the feature list of Airport can start at the basics, where you can list flights on the flight servers and take flights. Then we go up, as you get familiar with the extension, you can go into catalog integration, which means Airport can register tables. You can do selects and updates and deletes into those tables, because you can't really do a delete against a table returning function. Table returning functions are really just output only. Then we just talked about scalar user-defined functions, and you now have table in-out functions, where you can kind of use a table returning function as a pipe. Airport is authenticated, which allows you to make different changes with regards to what users can see particular data. So if you have some users that can only see certain columns and other users that can have another set of columns, the server can make a decision on what data to return to them based on their identity. So this allows you to do row level and column level filtering as well. So getting close to the end, when will it be ready? Soon. It requires DuckDB 1.2. It's MIT licensed, so you can pull it right now off of GitHub. I love it if you star the repo. It kind of gives me a feeling that people are interested and excited to do it. But come to the Discord and we'll talk about it. I think there's a bubbling type of level of interest that's out there. And soon I'll kind of publish a few Airport example flight servers to kind of give you all a head start on adding external services in this manner to use the extension. So I think we're ready for some Q&A. So I'm happy to hopefully give you some answers.
Thank you. Thank you, Rusty. Okay, this is a good question. Which of your many extensions are you the most proud of?
Airport is the most fun. That one is the one that I think the raw joy of having an external data set and then just having it into DuckDB without really doing much work is great. So I wrapped the entire AWS API. So AWS has 6,341 different API calls. I put them all into a wrapper, and they're all now DuckDB tables as well. So you can do select star from your EC2 instances, and that really gave me a little bit of joy.
But is it like asking somebody which of their children they like best? Is that how it feels? Or
I guess. I guess.
Okay, I'm sorry. But I was really impressed because I think people have mentioned this, that it's not yet trivial, let's say, to make DuckDB extensions, and you have really been digging through all of that to make this work.
Well, I would say the GitHub DuckDB extension template is the best start. Yeah. So it's not terribly hard to get started, and there are examples. So if you're interested, just fork that repo and get started on that.
Okay, so I have another question. Actually, by the way, everybody, great job asking questions. This is fun. And I don't have to run around with a microphone, so perfect. How does Airport mesh with existing extensions like Spatial or HDFS? Does it build on these, or is it completely separate?
It's completely separate. So you can install multiple community extensions at any time, and Airport is completely isolated. So if you're using Spatial, you can use Spatial and Airport at the same time. So if you grab data from Airport, you can run it through whatever Spatial function you'd like. Mm-hmm.
Another question that I think really interesting is which resources on writing DuckDB extensions do you find helpful?
The C++ source code. Yeah, definitely. I find the best way to learn was reading the source code of others. Sam, if you're here, I really have to tip my hat to Sam. He had...
Here's up here.
Yes, Sam is amazing. He wrote the original Iceberg and Delta Lake extensions, and he's written one called UC Catalog. And whatever Sam writes, I will read, and then eventually it winds up in an extension that I create.
Very nice. Then I'm going to read this one because it's more of a comment than a question. This extension rules. So somebody said that.
I'm glad to hear that.
And then somebody is trolling me and asking, do you think of adding graph support to DuckDB in form of an extension?
Oh, it's already on the slides, guys. I mean, come back here to this one right here. We have graph databases, Kuzu, Neptune, and Neo4j. You guys can add it yourselves, or we can write it for you. So stay tuned.
And a licensing question, how is the extension licensed?
Well, Apache, I believe, is the Apache license, and my license is MIT, and they're compatible. So it's just like DuckDB, I believe.
Okay.
Yeah.
Okay, I think, and then maybe this is the most upvoted question, so I have to ask it. Can we use Airport to scale out DuckDB?
Yes, you can actually. So inside a select statement, you can go to multiple Airport tables. So if you have a remote service that offers DuckDB on a different machine or a collection of DuckDBs running on different machines, you can just union them if you want to grab a result from all of those nodes. Or we could extend the extension to do multiple endpoints based on a list of hosts that you wish to query. So it's open source. We can do whatever we want.
It's freedom. Anyways, I think that's great. Obviously, everyone who wants to ask more questions can grab Rusty later. I'm very grateful for your talk. Thanks so much again.
Thank you.
And talk to you later. Yeah, and next we have Nati Clementi from NVIDIA, but she has her own laptop, so we'll have to... Yeah, let's come up. It's your laptop. We can't get into your laptop. Or maybe we can.
Oops. Well, somehow.
The time is also up, no?
Oops. Well, it's not. Okay. All right. Thank you, everyone, for being here today, both virtually and in person. Before we get started, there is a QR code there that's not the one for questions. It's the one that has all the slides and all the demos and everything I'm going to show today. So you don't have to wait until the end to see it. So you can grab it from there if you want. So a little bit about me. As Hannah says, my name is Nati Clementi. I'm a senior software engineer. This is where you can find me online in Blue Sky, GitHub, LinkedIn. And for the last few years, I've been grateful to work in so many open source projects as part of my work. And one of those has been IBIS. Here's Patrick. Patrick is IBIS mascot. And no, this was not drawn by a kid. It was a full adult, the one that did that. So I'm hoping that today we can learn a little bit more about one particular extension, like the geospatial extension. And then hopefully along this talk, I'm going to get some answers to you, why you should be using DuckDB to do geospatial analytics, and then why it might be a great idea to use IBIS to do that. So before we get onto the things, a little quick show of hands. Who of you write Python on your day-to-day? OK, almost everyone. Who would rather write Python instead of SQL? OK, come on, don't be ashamed. I know that they're watching, but all right, we got it. OK, so then this talk might be for you. Now, one of the things that I might not need to convince you, because you're at a DuckDB conference, is why you should be using DuckDB. And there are many reasons, but one of them is that these folks are really fast. And then you can use things in your laptop, and then you can get doing amazing things. As a matter of fact, the DuckDB folks have been outdone themselves, and in the last 3 years or so, they became really, really fast, like a 20x faster than what they used to be. And I'm expecting this year is going to be even crazier. So I would say we can just check that mark and then say that DuckDB is like, we should be using it. Now, why we should use DuckDB for geospatial? These days, we have geospatial data all over the place, and it's been becoming like very interesting to integrate with a bunch of your regular data. If you're not from the geospatial world, like there are a lot of the functions that map really well with like your standard SQL operations and then like databases and all that. And luckily, the folks at DuckDB in particular, big shout out to Max, that has been putting all this work on the geospatial extension. And then they work really well because it's based on traditional geospatial like libraries, and they have support for all these data formats. They're like 50 plus, so there's like geospatial formats all over. And as of 1.1, and I think 1.11 might be because it was tiny bug, you can read like GeoParquets from there, and then the geometries will show. So you get like all these good benefits, and we're going to see how this plays around. Now, I'm just telling you all this, but there is also people in the community that do more geospatial work than what I do. I just happen to write some things on geospatial, and I became a geospatial person. This is a disclaimer, I am not, so apologies if I'm not saying something, or if I say something that is not geospatially accurate. But some people in the community started using it. They used to use like something like PostGIS or different like other geospatial tools, and then they converted to DuckDB, and things now go from hours to seconds. That's, again, another plus for things are very fast. Plus, DuckDB has become really popular. It's like now it's everywhere. Everyone does benchmark comparing it. It's like everyone is looking at DuckDB. And that also means that libraries that are really good for geospatial things and plotting, for example, like Lombard, has an integration with DuckDB. So then it makes it easier that now you can query your data, do some analysis, analytics, and then you can also do some beautiful plots. So far, we got checked out why you should be using DuckDB. Probably, maybe I convince you why you should use DuckDB for geospatial. An extra thing that we have in the box is why we should be thinking more and more and integrating with GeoParquet. And this is something that is important because, as I mentioned, there were like 50 plus different formats to write things, meaning that they usually don't talk to each other, and that makes things more complicated. GeoParquet is becoming like more and more popular, which means that we're going to have a standard geospatial data in Parquet. It's like columnar data for geo. So it's like now your geometry column, it will be, has like data types for that, and things are going to be nice and easy. And there's going to be, or if so, there's already is more cloud data warehouse interoperability, meaning that you can just read from one place and then write to another, and then not being worrying about all this stuff. So as a plus, you also get the benefits of compression, meaning that like if you can save your data in GeoParquet, same as Parquet, you're going to be saving money because it takes less space. And there is also a really good integration with GeoArrow, which is a way of representing geospatial vector data in memory, making like things move fast between programs and things work like nice and easy. If you're interested more in knowing about GeoParquet and GeoArrow and how they play together, there's a great interview by Kyle Barron that I'll recommend you to check it out. So right now we cover DuckDB, Geospatial, GeoParquet. But what about the other bird on the room? So we're going to talk a little bit now about IBIS. I'm not going to go over like specifics of what IBIS is and in detail. There's a great talk about how IBIS works and then all the internals that was at SciPy 2024 by Gil Forsyth. So I recommend if you're really interested to know how IBIS works, then you can go check that out. But in a nutshell, I guess, IBIS is an open source portable Python library for data wrangling, meaning there is a data frame, it has a data frame API for Python, and interfaces with 15 plus engines. One of those engines, one of those backends is DuckDB. And it has a deferred execution model, which is like a bunch of words that probably don't mean much to you right now. But what it means is that the speed at which you query things is determined by your engine, not by like by your laptop. So if your engine is like running, I don't know, in a Snowflake, let's say, or somewhere, it's like that's what's going to determine how fast you're going to be executing things. So I said a lot of things, and then you might wonder, okay, but why using IBIS as an interface for DuckDB as geospatial? Well, if you're probably one of those people that said that you would rather write Python instead of SQL, then this is your thing. That person is also me. I rather write Python instead of SQL because I'm really bad at writing SQL. But let's see that more in action. So we're going to go into a demo now. I'm going to make this probably bigger. Is that big enough? All right. So IBIS, as I mentioned, is a Python library. It's fully open source. It's under an Apache license. So all the open source things, good things that you can do apply here. You can pip install it. You can conda, mamba install it, probably UV install it, and all the installs. And it works pretty easily. Like you import IBIS. We're going to get into this underscore thing in a little bit. And then you connect, you create a DuckDB connection. And in this case, I'm telling, hey, just include the spatial extension. Now, I'm not going to download the data live, because anyone that has ever done a demo knows that that's a no to do. But the way that you will do that is like you want to read, you do just connection, read Parquet, you give a URL to your S3 bucket. In this case, we're going to be playing with Overture Maps data. They have GeoParquet. Yeah, go check it out if you're interested in geospatial things. But one interesting thing that we can show is, at this moment, it hasn't happened anything. It's just telling me IBIS has a lazy evaluation. So it just tells me here, hey, I'm going to do all this stuff. So if, for example, I just run this filter, we can see here, it's just not very big, but like the way that you do filters, instead of writing like the SQL standard way of filtering things out, so you just provide the filters on, in this case, will be a bounding box. And then you say, hey, I want a box. In this case, this box is around Amsterdam. And then we're going to get some columns of data. And as you can see here, is like this is just kind of like a plan of what it's going to be doing. So we have get these columns and then filter them over here. Now, I'm going to go into an interactive mode where we're going to be seeing things more in action. So IBIS has an interactive mode, which means that everything I run, please execute it too. So we're just going to be reading this data. And then now we can see this geometry column here that we have some subtype. This is like infrastructure data of Amsterdam. And we get like some taxiways and probably other stuff. Among others, those other stuff, we get this airport. I don't know if maybe we can use the other airport that just happened in the other talk to do something with it. But then we have pedestrian information and some water information. So I figured, OK, if I'm going to be around Amsterdam, I might want to take a look at where I can drink water and when I can go to the bathroom when I'm walking around. So the way that you do that in IBIS is you can filter, and then you can see where the subtype is in either pedestrian or water. This underscore here is like a defer operator that tells me like it references the table expression that happened right before. So in this case, it will be this Amsterdam infra data, but sometimes if you're chaining multiple operations, then it will refer to the one before. Now, if I were to write this on SQL, this will look like something like this. And you can get IBIS to write the SQL for you. So then you can just go ahead and then try it in your installation that you do via Brew and the terminal and play in there, or write a whole string, your choice. Now, I'm going to just grab some useful information here. Again, like we're filtering by this class, and I'm grabbing what are the columns I want to play, what are the values that I want to play with. So one thing that one can do is, and here's where it comes some geospatial operation is, OK, I have all these data points, in this case points, so where is drinking water, where there are toilets, or where there is an ATM machine. And I want to see maybe if I'm around, let's say, the Van Gogh Museum, I have the longitude and latitude of the Van Gogh Museum. What are the points that are near that Van Gogh Museum within a radius of, let's say, 1,000 meters? So I'm going to make an IBIS literal here, which I give it a shapely point, and then that allows me to do this DuckDB operations on this point. So I have it on longitude and latitude. One of the operation that is common to do in geospatial is that we have things on a projection that, for the sake of explanation now, let's say we have like everything in longitude and latitude. If I want to compute what is like 1,000 meters from there, that coordinate system is not going to play well. So I need to convert it to something that understands what a 1,000 meter is when I'm doing all the math. So you can do an ST transform on DuckDB, or like in IBIS, it's called convert. And we now get this number that means something in this projection. So if I want to see, OK, what are all the drinking water points and all the stuff that are within 1,000 meters of the Van Gogh Museum, then I can just do this nice operation, and I see that, OK, I have a bunch of benches, a vending machine, some toilet. Let's just ignore the benches for now. So I can just tell it, out of the filter that we just did before, the underscore, now give me the ones that are not in category benches. So when I do that, I just get, OK, more drinking water, ATM, vending machine. Now, this on SQL will look something like it. Probably doesn't even fit on my screen yet. So again, your choice. But so just to make it like, and then to kind of be like wrapping up and then making this a little bit lighter, one thing that one can do is, OK, we get the distance to those places, and then we might want to plot this on a nice map. So I have some data too here that contains the polygons of an area near, the polygons of, all the polygons of the buildings in Amsterdam. And I want to filter the ones that are near, like, let's say, like 100 meters away from that coordinate of the Van Gogh Museum. So I can create a buffer around there. And then I can just like intersect, which is also another geospatial operation within there. And then, because DuckDB works really nicely with Lombard, and also I can give Lombard IBIS tables too, I'm going to be plotting. And we hopefully made a colorblind-friendly map, so tell me if it didn't work afterwards. But it's just plotting code. But here we have, we have the Van Gogh Museum, and then we have some drinking water at 173 meters, maybe a vending machine, I think, if I remember the code. So yeah, you can do all this plot and all this stuff, and and that way you can just write Python and, wrong slide. Write Python and not having to write SQL if that's the thing that you don't want to, and integrate well with all the other plots. So by now, probably, maybe I convince you why you should do DuckDB geospatial, and then why you might want to be using IBIS to do this. If not, then I'm happy to keep fighting outside, like later, over a coffee or a beer, maybe the beer will help. But yeah, let me know if you have any questions. Yeah, we have, here's everywhere you can find IBIS, the IBIS project, and yeah, that will be it. Went over a bit. I stole a few seconds.
Yeah, no, you did great. We are wonderful on time. This is very unacademic, I have to say. Thank you.
Recovery still, academic and recovery.
Yeah, me too. Yeah. Well, thanks so much for your talk. Really enjoyed it. I think as long as it ends up in SQL, we're happy. So.
You do the hard work. We write the nice Python.
Yeah. So the questions are coming in. So thanks everyone. So I'll start with the first one. Okay, this is a fun question. When will we be able to buy an RTX 5090 at MSRP? But that's just as a joke. No, the actual question, somebody asked, for example, linear interpolation is very difficult to write in SQL. Can IBIS help with that?
Linear interpolation as in like I'm not exactly
sure. I think regression.
Regression. So there is, if you're thinking of regression in terms of the ML regression kind of thing, there is also a module called IBIS ML, which actually uses an integration with like scikit-learn and all the stuff, but uses, let's say, DuckDB as an engine to compute some things. And there's some mapping in there. So that might be the thing for you.
Then there was a question, are there any major features missing in the DuckDB IBIS geospatial setup that would be easier to do by using another setup? For example, no DuckDB or no IBIS. I know it's a mean question, but it's like, I think the question, the positive way would be, it's like, how much is lost on the integrations?
On the integration. So there is like a great blog post that one of our former coworker wrote about, like, okay, how much overhead there is in IBIS, and there's pretty much none. So basically, you're using DuckDB, and the DuckDB is doing all the work. You're not losing anything in there, especially on the scale of the computations. You're not. I wouldn't say that you're losing stuff. At the moment, IBIS geospatial have some of the geospatial functions and some that are not. But the good thing is, if you're working with IBIS, you can also run raw SQL. If you want to write the SQL, you can, and then just run the SQL through IBIS. But then it will still like be computed by DuckDB. So, yeah.
And maybe a related question: which Parquet reader is IBIS using, or is it deferring to DuckDB?
Actually, IBIS is like using DuckDB for the Parquet reader. I think actually there is a default that it will default to PyArrow, but there is like an issue that I opened to kind of remove it and then use DuckDB's one. So I just haven't gotten to do the work yet. But.
Yeah, and I think also an interesting question is IBIS optimizing the SQL query it's sending to DuckDB, or is it just sending it out as is?
No, IBIS is not doing, as far as I recollect, like query optimizations, but it does have like a type kind of checking things. For example, if you want to compute the mean of a string column, it will tell you, hey, you can't do that, so it's not going to waste your time in that sense. No, it's letting everything to the engine, and basically IBIS is just like an interface to get to the fast thing.
Mm-hmm. And then is there another question I think is nice, are there plans for IBIS in the browser?
Actually, IBIS works in the browser thanks to all the work that DuckDB Wasm is working. Like if you go to PyArrow and stuff, yeah, you can do the same things that you can do with DuckDB, but with IBIS. So, yeah.
Okay. Thank you.
All right.
There's one question that's maybe for us, so I'll read it. And then, how much effort does DuckDB put into its interoperability with other languages through interfaces like IBIS, Python, or dbplyr R? We try. It is. I think the Python integration is definitely one that we bring features early too. I think that's fair to say. Mm-hmm. But sometimes you just have mismatches in sort of what you can express, but we try really to make that as painless as possible. Yeah, and also somebody praised your talk and said there was no beer necessary. He's excited, or they are excited to try it. Excellent. So thanks again, Nati.
All right,
and,
thank you.
And again, in an unacademic way, we are early for the break. So we're continuing here with the second question at 4:20 because we're in Amsterdam. So go ahead and grab a coffee or talk to each other. I don't know. Yeah? See you later.
I'm going to talk about my library called Yato, which is like a library that lets you orchestrate SQL queries on top of DuckDB. When you have like 10 SQL queries, bunch of SQL queries, guesses the orders, run everything in the right order. And so.
Cool. I look forward
Hello,
to seeing
hello, hello. Hello, hello. Yeah, there we go. Excellent. Okay, welcome back, everybody. It's great to see that you haven't run away in the break. But then again, we have been sort of, baiting everyone with beer later. So I get how that works. But it is now my great pleasure to introduce Mike Driscoll, to give a talk to us about something powered by DuckDB, which we greatly appreciate. So all yours.
Thank you so much, Hannes. Thanks. Thanks for having me, Hannes, and thanks to all of you who came out and to those who are listening in the live stream. Today, I'm going to be talking about a SQL-based metrics layer powered by DuckDB. I'm Mike Driscoll. I'm the co-founder and CEO at Real Data, and just really excited to share what we've been working on as a team. So what do I want folks to take away from this talk? A few questions I hope you get answered. One is, why do we feel, like many, that metrics are the core building blocks of analytics? Why should they be defined in SQL? Why is DuckDB the ideal engine to manage metrics? And finally, I'll speculate on everyone's favorite topic, AI, and how that can accelerate potentially metrics modeling and exploration. So just first, what's RIL? We're a BI tool. There's a lot of BI tools out there, but we are a BI tool that's uniquely designed to take advantage of DuckDB's incredible performance. We're optimized for OLAP engines, so slicing and dicing in RIL is instant. We don't hold back. We really design the experience of using RIL to be almost like driving an automobile with a stick shift. We also embrace BI as code, so big believers in local development and then being able to publish what you work on locally globally through Git workflows. And then really what I'm here to talk about today is a metrics-first philosophy. So at RIL, we think that you shouldn't have to actually design dashboards. Most of us, frankly, are not designers of dashboards. We're not good at picking colors and thinking about pie charts. With RIL, you design your metrics model, and then we auto-generate the dashboards. And in fact, we also auto-generate the experience you get with that dashboard. Okay, so I'm feeling lucky today. I am going to do a live demo of a DuckDB-powered metrics dashboard. Now, of course, with DuckDB, what's great is we can develop locally. So even if you're on a plane or you're at a conference and the Wi-Fi goes out, you can usually rest assured that you might be okay. So if you want to try at home, or you think you want to kill my internet connection, you can go ahead and download RIL with this curl command. It's very simple to do. I've already downloaded RIL, so I'm just going to make sure the version's up to date. Looks pretty good. And we're going to go ahead and actually build a new project called DuckCon 6. So RIL runs in localhost, opens up, and you have a few options. You can look at a template project, but what I'm going to show off today is how RIL is able to build a metrics layer from some data and then build a dashboard on top of that metrics layer in just a few minutes. And I've got some interesting data that I was able to scrape. A lot of public data out there. Lots of companies are, I guess, scraping public data these days. But I've got a GitHub scrape of every commit that's been made by the DuckDB development team since 2018. It's a Parquet file, my favorite format. I'm going to open it up here. And look, DuckDB on a Apple Silicon doesn't even blink, right? A few 100,000 rows. But there's an option here. You can see it brought in that Parquet file. It's giving us some profiling information on the side, imported the source successfully. And we have an option to generate a dashboard with AI. So we'll see if GPT 4.0 is still working right now. But if it is, what we're doing is we're making a call out to OpenAI. It's taking a look at a sample of that GitHub commit data. And just like that, we've actually built a metrics model and a dashboard on top. So just to kind of take a look here, what's happened is there's a dashboard file that's BI as code. Under the covers, that's a YAML file. We've got a source file, of course, that already came in. And then we've got this metrics model that defines about 10 measures. And actually, every time I run this, GPT gets a little smarter You can see it's defining a set of aggregate measures, total commits, total merge commits, average additions per commit, and then a set of dimensions that we might be interested in, like the commit hash or the username. So I can actually go to the dashboard here, and I can browse this locally. First of all, we can see some pretty good trends. The DuckDB team has been pretty busy since 2018, and I can zoom in on this one area right here and see that something was going on September 30th. It looks like there was, well, I don't know, there was a commit of 7,000 commits happen, and Tice J had, 7,000 commits on that day. I don't know if Mark or Hannes, what was going on there with this massive spike on that day?
Probably fixing CI.
Okay. All right. So we built this dashboard. If we wanted, we could actually go ahead and deploy that to the cloud. I won't do that. But we just started with a Parquet file, just a Parquet file of scraped commits. And we've actually built a pretty somewhat usable dashboard that we could probably clean up and go further. So that gives you a sense of why RIL, how RIL works, and really why we care so much about metrics. But just to go a step further, we think that metrics really are the right size building blocks for analytics. Fact tables are too raw. If I try to look at that Parquet file, I'm not sure I would get very far in terms of insight. But on the other hand, most reports are too baked. If I just gave you a PDF of a bunch of graphs, and frankly, we all look at GitHub Analytics a lot, you don't get a lot of insight when you just get a baked report. And so metrics are great because they're flexible. A metric is an aggregate function. This is quoting Julian Hyde, who's been doing some work on metrics in SQL. But metrics are aggregate functions that can be evaluated in different contexts. And so they've got shape to them. We all know that here revenue is sum of sales. But then there's these different contexts, predicate contexts. You can think about revenue in Europe or Amsterdam. You can think about time and looking at revenue for the last quarter or year. So the flexibility is really important when we think about analytics. That's the way we look at data all the time. Metrics are fast. So one of the things, of course, we love about DuckDB is it's insanely fast. But there are some memory limits, of what you can put even now on your laptop. And so being able to actually pack more kind of information into what you can put in DuckDB is great. OLAP cubes, being able to roll data up and aggregate them still can work for metrics, and it gets you about 10 to 100x less data than you started with. So that Parquet file, if I built an OLAP cube on it, might be 10 or 100 times smaller than what I started with. And then finally, metrics are intuitive. People have been tabulating ledgers and spreadsheets and pivot tables for centuries. So when we talk about metrics, things like revenue or sums, counts, and averages, those are things that business users actually get, they can make sense of. And so the flexibility, the speed, the intuitiveness of metrics are why we think it's really the right thing to build your analytics on. But also, as importantly, we think that metrics shouldn't be written in DAX or LookML or VizQL or all these other languages that have come along. This is I think this is Andy Pavlo, is that? From CMU. I think he's quoting from a Michael Stonebraker paper about how, the history of SQL is that NoSQL eventually becomes KNOW SQL. People basically learn SQL and they adopt it for almost everything. And I think we've seen that with DuckDB shifting left. More and more ETL is being done with SQL, and I think we will probably see more and more SQL shifting right, going kind of upstream of databases and being involved in BI applications like RIL. And then, Eric, I won't say his last name, but Eric B. from Modal had this great blog a few years ago. Look, no one wants to learn your garbage query language, right? So I think as developers, probably we should all be careful not to think we're going to do a better job than SQL. And maybe Hannes and Mark, you guys are the exception, because group by all is a pretty good syntax. So you can keep developing your own query language, but the rest of us shouldn't do that. And so in RIL, what we've really been working on the last, I would say, 6 to 12 months, among other things, is building a visual metrics editor in that tool, RIL Developer, that I downloaded and was showing off, where you can actually go in and you can define your measures, your aggregate measures, just in SQL. You can put case statements in. You can use all the power and the expressivity of SQL. It's Duck SQL, which is great. And then the other thing is that when you build a dashboard, Rill will take care of kind of managing that predicate context and thinking about the levels of detail. So you don't have to think about where clauses and group bys. You just have to think about that aggregate measure that you're defining in Rill. I just threw this out here because Julian is an architect at Looker who's been thinking about putting measures in SQL for a long time. I would be remiss if I didn't give him credit. This is not my, like most things, not my idea. And I would say we're early. What Rill's doing is not, we're not a pure SQL metrics layer yet. There's a lot of foundational work that has to happen. I'm optimistic that some of the work that's being done with DuckDB and your parser might actually allow someone like Julian to bring his ideas to life. Okay, so I'm just going to say a few more words about kind of the metric stack and how Rill operates, and again, why we think a metrics layer is really important, and frankly, what architectures we support for metrics layers. So a lot of what I would call legacy metric stacks are built on tools like data warehouses like Snowflake and Redshift and BigQuery. And a lot of traditional BI tools, Tableau, Looker, and Sigma, basically act as, I would call them like SQL compilers. They just kind of rewrite SQL and send it like down the transom. And I think one of the challenges with traditional BI tools is that there can be a lot of inconsistency in metrics definitions. Oftentimes you have to put the metrics definitions in every BI tool, which is a little bit dangerous. Also, many BI tools aren't really thinking about OLAP, so they're really just running regular, standard, full table scans on big tables. And when we go into customers, sometimes we just see some pretty awful things happening, and now Snowflake's not really incentivized to help their customers avoid full table scans. And then I would say the last piece is just in terms of dialects and coding languages. The nice thing about SQL is we all know it, and I think one of the reasons why JavaScript was very successful in terms of Node.js was that we were able to take one language and move it from client to server and kind of interchangeably. I think if we can move towards SQL on the right side of databases, not just on the left side, we'll have that same ability. So that gets us to what I think the architecture of a DuckDB-powered metric stack should be. Consistent metrics definitions. We can have a single layer where we store all of our definitions of what these metrics are. Obviously, you get the speed. OLAP queries are going to be much faster, and you get SQL everywhere, up and down the stack. So you can take predicate logic and you can push it down. We're already seeing that with DuckDB quite a bit. And I think that fabric, that data lake, I put Iceberg there, that is really going to be the universal data fabric going forward, right? I think that that's where the data lives, and all of us are just kind of living on top of that. Okay, but there's some challenges. It's not all peaches and roses. So data modeling is hard, and it does require some upfront pain. A lot of BI tools, a lot of folks that maybe aren't thinking about metrics layers, you just kind of can point at any table in your database, even including DuckDB, and get going. We do require that upfront effort. Now, of course, we're trying to lean on someone like ChatGPT to take that pain down a bit, but still, typically we have to go in and do some tuning. The second thing is that metric changes can be expensive. When you're building OLAP cubes, you change your model, you may have to rebuild those OLAP cubes, and that can be an expensive proposition. And then finally, and I know we're all talking about scale up as the dream, and there's some great examples of what scaling up or getting models to run on much smaller amounts of hardware, but single node scale still has its limits. And so for us, some of our customers, we work with AT&T, and Ericsson and Comcast, and those customers just can't run on my laptop, unfortunately. Not yet. Okay, and so I've got a minute left, so I want to speculate a little bit. This is, what can we think that metrics would, what do they mean for the world of AI? And I think you just saw that actually, it's actually not BS. We kind of surprised ourselves. More than 80% of Rill's metrics layers and dashboards are now built the first time around using GPT-4o. So it's been, I use it all the time. So it's actually one of those non-BS uses of AI. I think the other place where AI can assist is in optimization. So we're constantly thinking about how we can make DuckDB faster, casting strings to enums, thinking about column ordering and how skip level indices work. AI can kind of do some of that stuff automatically. And then I would say that if we think about what we like about tools like ChatGPT is that they're conversational. And DuckDB-powered metrics layers really are faster. And so you can actually have a conversation with your data in a way you couldn't if you're talking to a Redshift cluster that takes 2 minutes to return a query. So faster queries mean more queries, faster time to insight. And then there's a lot of rich metadata, too, that we annotate metrics with that we don't really put into traditional database columns. This is, I'll put these slides up so you can inspire yourself on your flight home or with further reading. But definitely, Julian High gets the credit for his work in SQL measures. And that's it. I'll take any questions if we have time. Thank you very much.
Thank you very much for your talk, Mike. I have a bunch of questions. Again, as we are returning from the break, QR code gets you to the Slido. You can ask and upvote questions. It does make my job up here easier, so do it. I have the first question is: does REAL work well for defining complex metrics that involve multiple sources and transformations?
It does, because those typically the way we would recommend is you do a lot of modeling into SQL, and then once you've got your we usually think of a one big table model. You join a lot of things up in just your DuckDB tables, and then you build that joined. You build your model on top of that joined table. So a lot of the complexity we're handing off to your tool.
Just let us do it. That sounds great. Excellent. There's a nice question. Do you see a psychological difference for users' interactions when they are using 60 FPS dashboards versus traditional, slower dashboards?
I mean, I think you could just, you can feel it, right? I think we all know what it feels like to have that kind of close to the metal experience. And what I can say is when people deploy their dashboards, the biggest complaint is, hey, how come my dashboard's not as fast? Because it's, now we're doing round trips to US East 1A. So even that 60 milliseconds for sure adds up, which is why we all love DuckDB on our laptops.
Yeah, no, we appreciate it that you like it so much. Then there is a question about the metrics. So somebody asked, I didn't see you defining the metrics. Can you explain how that works? Where do you define the metrics?
Okay, yeah. Well, you go into the, if I can actually find where I can, here we go. You go into the metrics view and you can actually change these expressions here. So it's basically part of Real Developer, but you also can fall back into what we kind of can call SQAML. This is SQL embedded in YAML. And so
that sounds a bit unholy.
But we think that most people are happy living in UI land for some of these parameters.
Okay. Yeah, very cool. Then maybe one more question. Have you considered replacing ChatGPT with locally run self-hosted models?
Well, it's been only a hot minute since I think Microsoft said, we're afraid all of our IP got stolen, and then the next day they said, oh, we're hosting DeepSeek actually on Azure. So I think, yeah, we'd be delighted to maybe host locally. I think it's a great idea for privacy reasons.
I could also rephrase the question as, how do you dare not having integrated technology was invented 3 days ago into your product yet? But, anyways, I think we'll leave it there for now. Thanks again, Mike. Let's thank Mike again, and we'll have...
Thank you.
And we have Ryan is next. I don't know, you have the laptop. Okay, thank you. Hey, good to see you. Is this plugged in? Okay. It's typing your password in front of many people is difficult. Yeah, there you go, all yours.
I'm very short on time, so I'll start straight in. Stock data analysis with DuckDB. So I'm hoping to give you 2 takeaways today. One is to demonstrate some simple, because I fear you all know SQL much better than me, some simple finance data flows and analysis using trade data, like the ABCDE demonstrated here. And 2, to demonstrate a tool I've created called QStudio that's like over a decade old, but by combining it with DuckDB, it's breathing new life and new abilities into it. So yeah, I'm Ryan Hamilton. I've spent 14 years building large data platforms in banks that basically enable quants and data analysts to perform an analysis of market data quickly and efficiently. Mostly I worked with one particularly niche database, because every time I popped my head up and looked for a really good one in the 14 years, I never found another, and I tried them. Apart from that, yes, I've found it time stored because I wanted to build a SQL client for that particular niche database, and then I made it compatible with 30 others, and we now sell some other tools to banks and firms, just to put it out. Okay, so what is a bank? Basically, it's a large entity that sucks in data and on the other side conducts trades and makes money. That's basically it. On the left, the most common data in the trading area of the bank, what comes from exchanges, so where trades are actually conducted. So London Stock Exchange, New York Stock Exchange, and if you're a big bank, you'll go to them all individually and put servers in every single location. If you're a smaller bank, you'll go to a market data provider like Bloomberg or Refinitiv that kind of aggregates it all together and gives you it in a nicer package. And that will flow in. And then on the other side, you're conducting trades for clients or on the external market. Let's dive inside the box to give you some data examples. So what I mostly worked on was creating a big data platform with that niche database and other tools around it to take all the data from the various exchanges and to horizontally scale it out, usually 20 to 50 servers globally, regionally queryable by individual teams there. Usually it was like a team of between 5 and 15 people to build it out, but it allowed them to query in under 200 milliseconds latency data very efficiently to get the real-time data or to perform large historical queries, usually maybe like 50 petabytes or something like that we would have. Okay, the reason we were doing this, not just for fun, one use case of making money is backtesting. So you've come up with a strategy, it's written in a little Python program. How do you know it's going to work? Well, if you were particularly trading Google, you would take it back the entire history of the Google stock, play it every day, and it would tell you if it would have won or lost money that day. That's one way to do it. So you plug it into the trading platform for backtesting purposes. Okay, so also within the bank, there's also typically standard storage platforms, Postgres, MySQL, MongoDB, everything. They'll have everything in there. And they'll have multiple ETL platforms for taking data from one, transforming it and pushing it into another. Okay, let's move on to our second use case. That's where data analysts, usually Python, sometimes SQL, sometimes Excel, will take data from one place and they'll either do two things. They'll generate a new data set or they'll generate an actual report, like PDF, to cause an action on the right. So if they generate an internal data set, that could feed into a trading platform or a trading strategy and go on and use that data to make money by executing trades. Or if it's an actual report, like a dashboard or PDF, they could hand it to a trader, it'll seep into his brain, and he'll use that to influence how he trades. And so yeah, a bank is data platforms, analysis, trading. And that's the very high-level view that if anyone here works in finance, it is entirely wrong, but it gives you an idea. Okay, so the reason this was highlighted in yellow, I think this is the area with most promise for DuckDB. And I want to dive into some of those analysis, show you some simple queries that will highlight why. Okay, so this is QStudio, the program I wrote 13 years ago, and I go File, New DuckDB database, and let's call it Bob. And up here I have a file I want to load. Well, first I will run that line, and then I'll start the file loading. So this file is like a 6 gigabyte kind of CSV that you yourself can download from the FTP on NYSE, New York Stock Exchange. It gives you all of the trades for one day, and each row is a separate trade. So this is QStudio. It's a Java desktop application that allows you to connect to 30 databases. It bundles DuckDB with it as of 2 years ago, which lets you do a lot of cool stuff. And I'll get to show some of them, but not all of them. I know you made the CSV loader faster. It's OK. So like I said, it's 5.6 gig. I think it will be 63 million rows. This live demoing is quite... There we go. Whew. And it loaded 68 million rows. And how the table looks is like this. So like I said, each row represents a trade. This is a trade for the symbol A with 59 units traded at $127.17. This time column is 7 a.m. And I've just added on 2 columns up here that if I scroll across, you'll see the 7 a.m. is in there as a time column and a timestamp on that date, just to make my analysis easier. Okay. I'm a little short on time, so I might skip one, but this just gives you an idea of the data that I'm selecting the total trade volume just by symbol, and you'll recognize some of these. There's NVIDIA, Tesla, and so on. We will skip the volume weighted average one and dig into some group buys. So here I am selecting by symbol, exchange, sale condition, and source of trade, the number of trades, the total volume, and the weighted average. First thing is, this is really fast compared to others, and I've tried loads. So it gets you very far already. What I've integrated on top, so if I go over here and I click the little pivot, imagine you're a new analyst, your boss says to you, I want you to go analyze that particular market, go see which are the most traded stocks, see which exchanges they trade on. This kind of pivot lets you do that. So I can say, I want to select the sum of the number column by symbol, or I want to select by symbol and exchange. And if I go back to symbol, and if I pop out the chart, I can say, okay, give me a stacked bar chart. So this is the total sum number, or maybe it would make more sense to do the sum total volume. And you can see the largest traded stock is OPTT by volume. And, oh, it's back the number. There we go. I'm a little disbelieving. Yeah, that's more like it. Tesla is the biggest one. Okay. Then what else can, yeah, I meant to pivot. So I can pivot on, let's say, exchange. And now the height still represents the total volume, but I can get a breakdown of where was the Tesla stock actually traded on which exchanges. And the cool part is DuckDB is doing all the work. So if I go to this little copy query, and I say, okay, I've copied my query, paste it back in. I need to move it down the line so you can see. But it was up top, pivot, the original select, and then using, and out of the 30 databases, and many that I've looked at in quite more detail, QStudio supports pivoting only in 2 of them, because only 2 are really good enough and do it much faster. And the cool thing is, like, QStudio does have a horrible pivot that works in other databases, but this is so much quicker, so much nicer, and I can copy paste it and take it elsewhere. My users are like, this is just like giving me a superpower. And Mike's point about the NPM, the server and client, that's very interesting, because what my users are using this for is they'll add a large server, they'll perform a query, and then they'll click this little duck, and it saves it to Parquet locally into the DuckDB database. And then they do the analysis locally on that subset, like these pivots. Okay, so that was one type of analysis for digging in and pivoting. Another thing that is very good with DuckDB is, I'm sure you've all seen most of you will have seen a candlestick chart when you log in to see your pension, maybe. And again, aggregating on time buckets is extremely easy. So a candlestick chart is just the open, high, low, close, where the thin parts are the min and max. And then the thicker part is called the open and close, which really just means in DuckDB is first and last within that aggregate. So the price at the start of the day and the end of the day, to let you see the trend from start to end. And like, it was just seamless changing the Oh, I've deleted the wrong one. 1 minute may be a bit optimistic. We'll try it. And it's fine. I meant to delete the 1 and leave the 5. But yeah, this kind of time bucketing we do all the time. Okay, I might just have time to show you how to make money. So for this one, I had to create a macro because you need time bucket to support the time column, or maybe I just didn't understand it. I am a novice at it. So let's pick one query, and instead of candlestick, oh, I didn't create it. Whew. Let's create the function. And now I can query it. And I went to the second query by mistake, but basically I had a blue line. Sorry, the red line is the price in 5-minute buckets of Apple. And then I have added on, using a window, the average price over order by time between 15 preceding rows and the current row. And basically what that is the moving average of the last 15 data points. And intuitively, when you look at it, you can see it's the moving average. As the initial value goes up, the average lags behind and then catches back up. So some naive, no, that's rude, basic investors believe that looking at charts is a way to make money. And it's called technical analysis, partly. But that's what you're going to use. I think it'll work for you. So what I'm doing here is I'm saying actually if I change this to something that you'll be able to see, 215, nope. If you wonder what I'm doing, there's something wrong with the font. Okay, there we go, 215. And 217. Okay. And if I run it, which one? Ah. Is that it now? Oh, it's turned it back to 1. I'm not going to be able to fix it. It would be too painful to watch. But basically what it would have showed you is the line up above, that when it's up, it's going up the swing, and you want to buy, and when it's going down, you want to sell. And if you did that, what you could then, this is really... You can see here, I've added on the buy column based on whether the moving average is above or below. And then once you've got that moving average, which DuckDB did very easily, you can then use lag to move it 1 position down. Because obviously what happened last turn, if it was up or down, you're going to use as your next action. And then to calculate the profit, you use lead to look at the step after that, because you took the action and then you may or may not profit it. And that would move it again. And that should give you, the full one of, you get a profit column, and then I can do the sum over the window of time. And if I scroll down, you have made 2 units of profit. All using window functions. Please don't do this. You will probably lose money for various reasons. This is not a stock recommendation. But yeah, I think you've seen how quickly I was able to pivot, how quickly I was able to do aggregates on time. And, there's the graph in the bottom right, where it goes up and down based on the purple block of buy or sell. And I was able to make money. Now, these are quite simple use cases. but hopefully you got the idea of how we use it in finance, and that QStudio has some quite nifty parts of DuckDB built in, and it's one of the only other databases that it does it with. I've been looking for this for over a decade. I tried MonitDB even back in the day. You can see other people are looking for this on Stack Overflow. They want first and last. They want to join two tables based on time, which is always finance, and you've got as of join, so I'm ecstatic. Like, I honestly have been waiting so long because like I thought we had a great system in this other database. The problem is it just never was friendly enough to expand, and I think you have all the attributes to be really good. Free, faster, easier to run, improving quickly, awesome Python integration, and those features. So I'm super excited, and I'm building it into all the products because it just kicks ass.
Thank you very much. Let's look at some questions. Yeah, this is the first question. QStudio was originally mainly intended for the other database, KDB+. How do you see the different use cases between KDB+ and DuckDB?
Definitely, currently, the solving of the Python analyst area, you have a very strong product. Really excellent there. It's up to you. Would you ever go into the large data area? Like
me?
Well, it's not on me.
Is KDB? Are the other? No, I mean maybe. I don't know. But so the different use cases, you would say that the KDB Plus is more for these like really huge things, or?
I think KDB can do both of those. I think yours with the much stronger Python integration and being free. Like for years, I worked in a different one that was a very good tool, and friends would come to me with these time series, large data problems, and I would love to recommend it, but it's hard to get into. DuckDB is so approachable, and I really think it could have solved so many problems that I've seen in the past, and there's enough of those that I also want you to make some money, that there will be use cases on top where people are very happy to pay. So yeah, I think there were always those problems there, and now people have got a solution to it, which is pretty exciting.
Thank you. Maybe one more question, because we're a bit short on time. I work for banks, and more than 50% of my files are XML. Thanks for the laugh. Could you possibly handle these? Do you have any ideas of any experiences how to handle those?
No, I'm now offloading all of my processing to DuckDB. So people can, in Windows, double-click to open Parquet and QStudio, and just whatever the underlying ones do, I would support. So it's pretty cool. So
we are not planning XML integration, but if you want to write a community extension to deal with it, you are very welcome. Okay, well, thanks again, Ryan.
Cheers.
So now we enter the madness phase of this event, where we have, I think it's six lightning talks in 35 minutes. So we are going to do questions during the lightning talks, but probably only going to have time for one or two. So you have to be quick. Well, it's like the lightning talks, you have to be quick, so wake up. Then, let's get started with the lightning talks. Djurd is the first speaker. So Djurd is a fellow colleague from the Radboud University. We're up on slides. Let's see. Hang on, we're still not up. We have to wait for a second.
Is there a stopwatch? 5 minutes.
There is a timer up there that will be showing you the time. And we just have to get the slides up. It's HDMI 1 apparently.
I made them in LibreOffice, and it was a big thing to get them here for some reason.
Okay.
All right.
It works better if it's plugged in. Sorry, people.
All right. Maybe I can just start without slides.
Hang on.
Or can I get some extra minutes?
But I'm not going to give you extra minutes just because we screwed up. Okay. Oh, duplicate. Yep. Okay. That makes sense. Now, hooray. Okay, all yours.
Thank you, Hannes. So, wow, I'm impressed by the crowd. My name is Djurd Hiemstra. They're going automatically. That's not... Okay. I'm not that fast a talker. So, I'm teaching the introduction to databases at Radboud University, and Hannes is doing the data engineering course for the masters, the really tough things. So I love DuckDB. We use it for the introduction to databases since a couple of years. My research is into search engines, and I had colleagues like Arjen de Vries, and also Hannes published a paper in 2014 using column stores for search engine research. And I even used MonadDB as well, and I always thought, this is really cumbersome, and it takes a lot of time. And until last year, so we're now doing lots of our research in search engines using DuckDB, and we called it Zoekend. So it's like search duck for the people that don't speak Dutch, which my colleagues thought was a horrible name, internationally very bad. But here it is. So this is my terminal, and I type Zoekend, and what would you do now? No, never used it. -H, of course. So then you get this really cool things Zoekend can do. It can index, it can search, can evaluate your results. So it's all making very fast prototypes. So here, there's these things that we can do now. One of them is CIF import, which was presented by Arjen de Vries at some earlier DuckCon, and it's also his code. And here is our Git repository, and you'll find that every one of those commands, the sub-experiments, are little Python files. So the idea is, as a researcher, you can write your little Python file and then include it in the Zoekend, and we can reproduce your cool search engine results. And this is my secret. You can make a very nice argument parser that does all of this for you. But the real secret is that all of our experiments are done. So this is basically the Python code, right? So like con.sql and lots of cool stuff. And it's really powerful. And as I said, it's now also really fast. So we're doing like serious benchmark test collections with millions of documents, and it all runs within, well, like I cannot even drink a coffee. It's really great. So the code that I just saw, it does the following. So one of the things that we're investigating is making very efficient search engines. And most search engines, like Lucene, which is I think the #1 open source search engine used by Wikipedia and lots of other big companies, they store an inverted file, which is basically the file in the back of your book. For every word, it's the documents. But they also store all the document lengths. And if you have 1 billion documents, you have 1 billion document lengths that are stored, which is really weird. Why would you do this? Well, it has to be done for the ranker. The ranking computes scores, and they need the document lengths. So we had this idea, let's remove all the document lengths and try to approximate them. It would be really hard to try this with Lucene, because it's all very much hardwired in the code, and there's bunch of very complex Java code that does this. But we store our indexes in DuckDB, and so I can just do alter table, drop column length, which drops all the lengths. And by the way, DuckDB, the full text extension, which is great, also stores all of the lengths. So here is for the robust 04 collection, which is a collection of about 1 million documents it's used a lot in search engine research. These are all the document lengths, and I sorted here the documents with document #1 is the longest document, and document number 1 million is the shortest document. You see that it kind of follows a straight line in a log-log graph, except for the long tail is missing. And here are some results, and this is unpublished results, so you're the first to see this. And here we measure the quality of the search. So we want to know if we do this, and if a future me builds a very fast search engine, will the search results be good? So this is how well would the users like my search results? And in various experiments, some of the times actually by approximating the lengths, the scores go up a bit or they go down a little bit. But actually, there's no significant difference whatsoever. So we can, in the future, build these very fast search engines. So that's basically it. I said 5 minutes is up. Oh, 10 seconds. What we've done is there's some students, Sam and Daniel did actually some of the exercises for this, and Timo and Yannick are doing bachelor theses using Zook8, and you follow me on Mastodon.
Thank you.
Yeah.
Thank you. Thank you, Jared. Okay, there's one question. Can we replace OpenSearch with Zook8 and will it be more user-friendly?
Can we, replace what? OpenSearch?
OpenSearch.
OpenSearch.
I don't know what it is.
Oh, that's the Amazon where they took the other. Yeah. No, not really. This is more replaced. There's systems called like Terrier or Anserini where people use Lucene to build. This is more search for researchers, so doing easy experiments. But it would give hints, I think, to make a much faster OpenSearch. Yeah.
Well, thank you. And now we move to the next lightning talk.
Thank you.
Thank you.
Okay.
And the next speaker is Daniel from the CWI, where DuckDB was created in the first place. All yours.
Thank you very much, Hannes. Yeah, my name is Daniel ten Wolde. Good afternoon. As I said, PhD student at CWI Database Architecture Group. And today I'll talk to you about how you can unlock graph analytics in DuckDB using SQL PGQ. So the data model that I'll focus on today is the property graph data model. And this extends the normal graph with labels. So every node and edge can have a label, such as person, city, lives in, and follows. And every node and edge can have properties in the form of key-value pairs. So how you would store this in your relational system is actually with the following schema. And there's not much special going on here. For every label, we have a different table. And the properties are columns within these tables. So now we are tasked with the following prompt, where we want to count the number of people that Bob indirectly follows living in the city of Utrecht. And in today's SQL, you would have to write the following. And it's a bit of a jump scare style query. But this yellow part highlights the recursive statement. So you recursively explore the paths. And, well, you have to keep track of the path yourself using an array. And I would argue this is not really nice to read, not really nice to write. And from a systems perspective, these are also pretty difficult queries. So what can we do? Well, as part of the SQL 2023 standard, yes, there is a SQL standard, it introduced SQL property graph queries, or SQL PGQ, which allows you to create a property graph layer over your already existing tables. And then you can use a visual graph syntax to more easily do pattern matching and path finding. So the first step of SQL PGQ is to create your property graph. And in this case, we give it the name social network. And we explicitly define what are our vertex tables, person and city, and what are the edge tables. And for the edge tables, we also have to define the source of the edge and the destination of the edge. And we define the keys that we'll use to join later on. OK, so after creating our property graph, we're tasked with the same prompt. And now in SQL PGQ, you would only have to write the following query. And SQL PGQ introduced this from graph table over the property graph that we just created. And then this visual graph syntax. So nodes are denoted with round brackets, and edges are denoted with square brackets, and these ASCII art style arrows to denote the direction. And this indirectly follows. That has been reduced to this any shortest. So any shortest path between person 1 and person 2, and this cleany star. And a cleany star means there can be 0 or arbitrarily many hops between person 1 and person 2. OK, so if we compare the two queries, SQL PGQ is about 4 times shorter, and even more importantly, it's a lot more readable, I would say. So how can you do this in DuckDB? In DuckDB, it's installable as a community extension. And our approach, I won't go into too much detail now, but we translate the PGQ-style queries to standard relational query plans. So then we can use DuckDB's very nicely performing execution engine to run these queries for us. And actually, on benchmarks we outperform the leading graph database system, Neo4j. We outperform them by 10 or 100x on some analytical queries. And in the case of pathfinding, we introduce special UDFs to handle these more efficiently and a specialized data structure. But as a user, you don't have to worry about all of that. You just use the nice syntax. And finally, we also added some graph algorithms in the form of table functions, such as PageRank, weakly connect component, and local clustering coefficient. And this really allows you to do all your graph analytics within the DuckDB environment. So whoever asked the question earlier if DuckDB can be a graph database system, yes, using DuckPGQ, you only have to start DuckDB from any environment, and then type install DuckPGQ from community, load DuckPGQ, and you're good to go. And finally, there's a QR code that leads to the website where there's more documentation, more examples, and that was it. Thank you very much.
Thank you. That was excellent. And I have to say, this is a really impressive extension for DuckDB because it's, it's modifying the query language, the operators, everything, the optimizers. It's involved. So well done, you.
Yes.
Yes. Extra applause. Yes. Okay. So there is a couple of questions, but maybe let's just look at one that's relevant to what you did. So. How does DuckDB in general handle loops and recursion in queries? And what strategies would you optimize to optimize them?
So we don't use the recursive operator ourselves actually for these pathfinding queries.
Yeah.
That's where the specialized UDFs come in with a breadth first search algorithm. And we use data structure to also more compactly represent the graph internally. So that's how we would do the recursive exploration of the path, actually.
And I have one more question, because I also like this question. What are the pros and cons of PGQ versus Sparkle? Sorry.
Completely different data model, but...
I'm sorry?
It's a Sparkle, yeah. I wouldn't know. Not sure.
It's a bit of a question. Thanks so much again. Yeah, now move to the next lightning talk. And for the next lightning talk, we have Christophe, all the way from Paris.
Yeah, perfect. Okay.
All right, all yours.
Is it on? Yeah, okay. Hey everyone, I'm Christophe. Today I'm going to talk about Yato, which is a small package library that I've developed, which is the smallest DuckDB SQL orchestrator on Earth. It's not that complicated to do, but I'm the first one, so it's the smallest and the first one, I guess. In the audience, I guess we all love DuckDB, at least in this audience and maybe online. And actually, DuckDB feels like magic. I guess everyone agree in the audience, because what you have is you have data, like CSVs, buckets, whatever. You create a SQL query, and then you get results, and everyone said it. It's fast, it's magic, it works, it's for analysts, and everyone is happy about this. But there is something in real life that we don't show when we do this, which is actually life is like this. We have a lot of files, we have a lot of tables, and a lot of SQL queries, which leads to a lot of results, which can be annoying because it means that you have to manage a lot of SQL files. You put it in the folder, you have to orchestrate everything at some point. And many solutions exist, actually. There is the most popular one, which is dbt. I know a few people talked about it and know it. There is like a lot of companies in the transformation space that are doing this. That's why I've created yet another transformation orchestrator, so called Yato. And the goal of Yato is quite simple. It's like the goal is to take it simple, stupid, a bit like DuckDB in the context of you just do DuckDB and you have a database locally. It's the same for Yato. You take a folder with a bunch of SQL queries. Yato will run on top of DuckDB. The SQL is the correct order and create the tables. And that's all. There is one parameter, which is the folder you want to run. So I will do a small demo. That's the moment you have to bear with me because I will type on a QWERTY layout as a French. So, not this one. Oh, I will not zoom in. So I have a virtual env with my library Yato installed on it. It's Yato lib if you want to install it because Yato was already taken on PyPy. In the folder, I have at the moment nothing. So what I will do is create a source SQL file. So for instance, I do select 42 because why not? And then I will create another one called final.sql, for instance, where I do select sum of value from source. And I remember that I have to put the alias on source. So we'll go back on source, then put the alias as value. And then what I just have to do right now is Yato run dot. Where is dot? This one. Oh, interesting. That's not something that meant to happen. It was working a few minutes ago. Let's try again. It's not working. OK. So I will try with another folder. Maybe it's going to work. I have a folder with examples. So this one, for instance, I have to put run maybe first. OK, it works. So this one is a folder with a lot of queries, which is like the example folder from DBT. It's called Jaffle And so it ran. And what I have now in my folder is a Yato DuckDB database that I can open. Yato and do show all tables. And I will get all the tables already materialized within my Yato database. The funny part is that I will show it on GitHub, on the repo. It generates also a mermaid diagram, so you get the lineage. So if I get into Jaffle there is a lineage here, and it generates like the lineage for you, so you get all the dependencies between everything. No, it's not this one, it's not this one, it's this one. That's all. There is the repo on GitHub. You can scan it on the QR code. This morning I had 199 stars, so maybe can someone be the 200 one? Be my 300. Ah, cool. And who I am, sorry, I'm Christophe. I'm an engineer and a geek. I do content creation. I have a weekly newsletter, a blog on dev.fr. And at the moment, I'm building an AI code editor for data teams called Now. Thank you.
Thank you. Thank you very much, and mad respect for doing a demo on a lightning talk. This is. So we have some questions. Does it use dbt lib internally?
Nope.
Yeah, I thought so.
Only SQL glots to understand what are the dependencies.
Any hopes of getting column level lineage in the mermaid? That sounds wrong.
I would love to. This is something I'm looking for my company. So maybe it's gonna be in like Yato.
And there was maybe one more question. Can we get rid of Kedro in favor of Yato? These are all words that mean nothing to me.
What is Kedro?
There we go. Probably. Thank you so much,
Thank you.
Christoph. And we have the next lightning talk. Done by Sam, and in case you accuse us of only inviting people that are, positive about DuckDB, we thought we'd invite Sam to, to work a bit against this assumption. Have fun.
Hi everyone, I'm Sam Jewell. I work at Grafana Labs, and yeah, we had an interesting time. We got a few scars, and so I'm excited to share with you how you should not go about using DuckDB. So Grafana's kind of tool for visualizing and dashboarding your server monitoring and observing the state of your servers. We've got our own backends for like metrics, logs, and traces, but Grafana is super powerful. It can get data from all kinds of different data sources, and you can combine them in one dashboard. You can even combine that data in a single panel. And so here, for example, you're writing different query languages. You can write a logs query up at the top there against a logs database, a SQL query against a SQL database, and you can like try and combine those and visualize them in a single visualization, you know. And you can do that with like a metrics backend, like Prometheus, for example, or Graphite. Don't know if these words mean much to you guys, but or traces or JSON or CSV responses from like API endpoints. But don't try and read this slide. It's just to show you that it was a bit hard and complicated for users to actually do this. And we realized that the data you're getting back is tabular, right? We all love tabular data. What do you use to work with tabular data? Well, SQL or Python, maybe, So we stuck a SQL editor in there. We used SQLite, but it was too slow, really. So in a hackathon, we thought we'd throw DuckDB in there, try and speed it up. And it was faster. This was going to be our transformer, so we were going to call it Optimus Duck. And it was super fast. We got really excited. We got it shipped to a couple of users behind a feature flag. And I kind of moved right across engineering to like work on this project as well. But we had forgotten to read the manual, basically. The first thing I worked on, having moved teams, was a security incident. DuckDB CLI has a dot command that allows you to run shell commands. This is what I woke up to one morning. And it's in the docs right there, the shell command and the system command at the bottom there. And we kept exploring. We soon found like read blob is in there too. You just like type this inline in the SQL, and there's a bunch of functions for reading files, right? Many of you will know this, but it's important to know it. And so Grafana faces a lot of users. There's a single instance running. It's got many users, sometimes many orgs as well, organizations sharing a single instance. And so any user that didn't even need to be an admin could write this and read secrets and read files off the host machine. So pretty bad. So this, in security speak, this was, the dot commands are remote code execution vulnerability, and the other is like LFI, local file inclusion. And this is not unique to DuckDB. These are features. They're not bugs. This is not unique to DuckDB either. This is like in MySQL, you get similar things, for example. And I'm not going to read this whole slide. The security impact wasn't too bad. There were like a couple of customers we had to switch off the feature. We checked every log line, no evidence of exploitation. But it took us a lot of effort to remedy this. We had to kind of like, Grafana's open source, but we can't push the change into the open source repo because that would kind of create a 0 day. We have to like get the change into the private repo, rebuild a bunch of binaries. We learned a lot, and that's why I'm here today, is to share our learnings with you as well. How did we even get here? Well, we were implementing on the back end in order to support alerting, and the back end's written in Go. There is an official Go client, which is great, but it uses CGo. And we target so many, we build so many binaries for so many different platforms, like including kind of IBM mainframe platforms, that it's impractical for us to be running like a C tool chain to compile all of these, to compile loads of different C for all these different platforms. So that's why we turned to the CLI, and that didn't go well. So I guess I've got 2 lessons to share, basically, simple things. Use the embedded version, don't use the CLI. That removes the dot commands, the shell command, and still in the docs, just read all the docs. The page on security DuckDB says, how to disable the file access as well. We still think DuckDB is a fantastic tool with great potential. Just remember to read the manual. So yeah, that's me. Thanks.
Thank you very much. This is excellent, and I think it's something that we also learned from this is to just to be a bit more sort of outgoing with saying these things. So what have you actually done to fix this?
For now, because of the Go, wanting to avoid the C toolchain is like so valuable to us. For now, we're implementing with like a SQL engine that's vanilla Go implementation. So it's actually a MySQL Go SQL engine, that we're running for now. But I was just talking earlier with Mark about like how much would it take for us to like transpile all of this C and C++ into like native Go for DuckDB.
Okay. And one question maybe, why this code was running on the back end and not in the front end with, for example, WASM? Is that just architectural?
Yeah, we tried that. One huge factor is like the size of the JavaScript bundle became like pretty enormous. And like in the same way as Grafana's, like we have like 1 million Grafana instances running in the wild, and some of them are running on Raspberry Pis and at the edge. And we're like proud of that, and we want to like improve, grow that, not shrink it. And so we grow that opportunity by shrinking the JavaScript bundle. And so the WASM thing was like pretty big and heavy. And then alerting, you just want every piece of functionality to work with every other piece. And alerting is on the back end and needs to be implemented on the back end. But yeah.
Okay, very good. Thank you very much.
Yeah, thank you.
And we got two lightning talks to go. We're almost there. Next one is going to be Adam. Yes, there he is. Excellent. So yeah, all yours.
Great, thanks. So yeah, I am here to talk about this Bootstrap product that we created on top of DuckDB. So what does it do? It solves a simple problem, and that is the access to transactional data from lots of bank accounts. The average person has like between 2 and 4 accounts. The average business has about 5 or so transactional accounts. And large businesses obviously have a lot more. So there's a lot of time spent just manually extracting data still out of these types of systems. So I was looking around for a solution that wasn't in a piece of accounting software. And there was also a lot of other people who were experiencing the same stress. And as you can see from the Source of Truth Reddit, this is just like a few of the many hundreds of people. So what is CloudSlep? CloudSlep is basically a syncing query engine that pulls data out of all the individual bank accounts. And then you can create SQL templates that you can reuse over and over again through an API, and you can embed the API call in, say, like a Google Sheet or in your own analytics tool. So yeah, it builds up a long history of the transactions data, and it combines accounts from multiple people. This is what the UI looks like. It's quite simple in terms of that. It's got some instructions, so you can type in human language-based list of things to do. It runs through a llama model and spits out a SQL query. And at the bottom here, you can just get a preview of the data using DuckDB WebAssembly. And over here, you can see all the export options you've got, so you can download the file. There's just a simple instructions for embedding it into Excel or Google Sheets or APIs, or you can actually use it in a custom GPT action as well. And then so you could ask GPT about your financial data, if you're feeling brave, I suppose. So some other kind of simple use cases that we have, just complex formatting, write a big instruction, just changing formats. And then we've got another case here that's data enrichment, so adding columns. You have access to a SQL editor inside it, of course, because it's DuckDB. And then we also have this decision log, which is the LLM that we're using runs through a React model in Python. And so it's like first gets the available table, and then what are the fields. and then based on what they've put in, it comes out with like the steps that it needs to take, and then it executes the steps, and it actually tests the queries that it comes out with against the DuckDB in sequence, figures out which are the good queries, which are not the good queries, and gives back the end result to the user once it's happy it's found a solution. Yeah, these are the export methods that we currently do. Probably add some more soon. Yeah, that's basically what I explained. We're trying to go for the more advanced descriptions, so beyond just simple text to SQL towards the more advanced, big instructions, and eventually have whole workflows just written down in text. Yeah, so how we're using DuckDB, basically in 3 formats, one in the browser, one in for pre-processing in Node.js, and then also in Python as well. Yeah, some other things here. This is our architecture diagram. And yeah, there's some really useful things that have come out that we've put in and we're using actively. One thing I would quite like is if we could just turn off the type altogether so the AI doesn't get confused. And we just put everything in varchar, but I know that's probably a bad thing to say. So yeah, that's it. Thank you very much.
Thank you. Thank you, Adam. Let's see. I don't have any questions right now, but maybe I can ask you a question. So I didn't exactly get what the LLM was doing in the workflow. You're getting the data from the internet, and then what happens then?
Yeah. So what it does is it just takes the user's question, converts it based on the standard transactions table format into SQL.
Okay.
But it does it through lots of steps. So instead of just like running it once through, it might look up some values and output a longer SQL statement. So it might not be the best quality SQL statement, but the concept is that the answer is the most important thing. It is correct. So, yeah.
Thank you. Excellent. That's excellent. Then we'll go to the final lightning talk. And thanks again. And we have Tony, who is winning the Best Dressed Presenter Award. And for the final lightning talks, all yours.
Well, thank you. You know what they say, you keep the best quack for last, so let's get quacking on. Today I'll be talking a bit about some data engineering use case with DuckDB in healthcare. So something about me, I'm a data engineering consultant. I consult healthcare and biotechs on their data engineering strategy. I'm going to talk today about a use case at Curative, which is a leading health service provider in the United States, focusing on bringing a new health plan in the market that improves things through engagement, cost, and transparency. So just a very quick overview of what the tech stack is. We'll have various sources like APIs, Kafka streams, upstream databases. We will load this through SaaS tools like Fivetran or an orchestrator. We have Prefect plus DBT. We get that into Snowflake, and then we transform with DBT. And we generate some reports like PDFs, Looker dashboards, eligibility files, you name it. So one of the use cases I wanted to talk about is data protection. So as you can imagine, in healthcare, we're dealing with a lot of PHI and PII. So we have a lot of accreditations that we need to implement a lot of security practices for. Think of HIPAA, HITECH, FedRAMP, SOC2, and a whole bunch of others. And as part of this strategy, we've developed a dynamic data masking system that allows us to mask over 10,000 tables and views and 100,000 columns for various different data sources. And this allows us to essentially say, whenever someone's querying the data based on some metadata of this user, are they able to see the data or not? So very quickly, how this works is an analytics engineer might have a pull request against GitHub, goes through a CI pipeline on BuildKite. We use Prefect plus DBT to build this out into Snowflake. And we then have DBT artifacts generated. And as we are defining all the, let's say, policies through the YAMLs in DBT, we can then essentially join that data together from Snowflake and DBT with DuckDB to generate the SQL statements we need to actually apply these masking policies. So for this, we use tag-based dynamic data masking in Snowflake. So essentially just add tags to your objects, and then if you configure it right, the dynamic data masking policy is automatically attached. Now, Initially, we've done this purely in DBT and took us almost 2 hours in production, which was slow. But with DuckDB, as you can see, it was 5 minutes. Most of the time was spent getting the data in and out of Snowflake. So it's just the second use case I want to highlight quickly is integrating healthcare data. So as I mentioned before, we also have upstream databases. So these are operational databases that have all kinds of data from the health plan. And we essentially want to get this stuff out quickly and reliably. And in some cases, that means that we need to build our own to really build it to the standards that we want. So here we've also used DuckDB as more of a pipelining tool. So you might have some upstream databases. We use SQL Alchemy to extract that data out. We create some arrow streams that we can then just stream into DuckDB very efficiently, do some light transformations, resolve the schemas, and eventually write it out to Parquet on S3, which we can then easily dump into Snowflake. And the nice thing about this is we have the Datadog integration of most of these steps, so we're able to do a lot of APM, profiling, query latency analyses to really see where the bottlenecks are in our process. And we're also working on getting some DuckDB profiling data included in there as well. So that was my lightning talk. Thank you for listening.
Thank you. We have a question that I'm also curious about. How do you get data from Snowflake to DuckDB? If anybody wanted to do that.
Why would you want to do that? I don't know. Yeah, that's an interesting question. So there's a few ways to do it, but what we do is we basically use the Snowflake connector to extract out batches of Arrow data. They just support that. And then with some small modifications, you can create a record batch reader that goes straight into DuckDB. It takes some engineering. It's not like out of the box, but yeah, it's also not too terrible.
Very nice. And maybe one more. Have you looked at replacing DBT with SQL Mesh in your package? I don't know these things.
The answer is yes, but it will take some time to test it out. That's the answer there, yeah.
Excellent. Well, thanks again, and excellent talk.
Thank you. Awesome.
Thanks. And now I will, indeed, I will say some words still. It will only take like 20 minutes, don't worry. Okay, so I just want to point some things out. So we have Michael Simmons, one of the authors of the DuckDB in Action book, actually with us here tonight. He's there, very good. And he's going to be, yes! And he's going to be sitting outside signing books later on, and I think he's also a stack of books that he's giving away in the process. So you might get your hands on the book with a signature later on. I also wanted to point out that we are going to have a poster session later during the social part. Here's the list of posters, and that's really sort of because we had just way too many good proposals for this DuckCon, and we just couldn't possibly fit everyone in the program. So we have some people that we really like you to talk to, but couldn't find time in the general program as posters, so please do talk to them as well. I want to again thank our wonderful sponsors, Monday, Real and Crunchy, for sponsoring today's event. We wouldn't be able to keep it free for everybody and still provide snacks without that, and obviously have this wonderful room, live streaming, all that stuff. So thanks a lot to our sponsors again. And that was it. So we'll now go to the social event. So thanks a lot, everybody, and talk to you in a bit. Thanks.